Morning all, and today I'm going to review this mobile power bank. Now firstly I'm just going to run some shots I took when I first received this thing to remind you what my impression was of it when I got it, and then I'll come back and let you know what I think about it now that I've had a couple of weeks to use it, and after I've done a capacity check on it. There it is, and it looks lovely, doesn't it? Looks absolutely gorgeous. Black with this deep red coloured band around the outside. We have two USBs, if I can get them in the light. Yep, so we've got a 5 volt 2.1 amp and a 5 volt 1 amp. Got an LED light and also a 4 LED bar graph to tell how well it's charged, and a button and an input socket, and that's it. This is very much a no frills power bank. Now it may not have many bells and whistles, but what attracted me to this power bank was the capacity. Look at this, 22,400 milliamp hours, 22 amp hours. That's awesome. Now I'm going to do a full review of this power bank in its own video fairly soon, but I can't help trying to think what might be inside this. So here are a couple of 18650s, and it looks to me like what it might be is 2, 2, 2, 2. So I think what's in here are 8 18650s, and it's heavy. It's really got some weight to it. I mean, it feels solid. So 8 18650s. So 22400 divided by 8. Let me just get my calculator. So it's 22400 divided by 8 cells, which is my guess, comes to 2800 milliamp hours per cell. Now that's a sensible number, so I think I could well be right that there are 8 18650 cells in here. That's a lot. So I'm going to play with this thing for a few days, use it to charge my devices. I've actually got my phone, the phone I'm filming on now, plugged into it right now at this moment. So that's drawing half an amp. Now the phone's fully charged actually, so it probably won't be drawing that for long. 2.5 to about 3 watts. And the voltage is hovering at about 4.9 volts. So I've been using this thing for a couple of weeks now, mainly to charge my Nexus 7 tablet, which I tend to do overnight, and it can do 3 or 4 or possibly 5 full recharges of the Nexus 7. Now in those clips from a couple of weeks ago, I guessed that this power bank contained 8 18650 cells, and lucky for me, Lewis from EC Technologies sent me some images, so I haven't had to take this power bank apart. So you can see there that I was absolutely right. There are 8 18650 cells in the power bank with the circuit board squeezed up at one end. Now these cells are ASO cells. Now if you do a search on Google for ASO 18650s, you get very little. There's a couple of can you help ID these 18650s from a laptop pack, both on Candle Power forums and Budget Light forum, but this is essentially the same item on both forums. And this is a guy who bought a laptop pack, an unbranded laptop pack, which contains these ASO cells, but of course he didn't know, and we don't know, whether these were brand new cells or whether they were used. So the proof of the pudding, as they say, is in the eating, and that's where this thing comes in. This is a little charge adapter or power bank tester. This one specifically a power bank tester because it remembers the milliamp hour value even when you take the power off it. So I ran a full charge on this thing, and incidentally this takes over 12 hours to charge, I found, and I was charging it with this. This is the Asus or Asus charger that came with the Google Nexus 7, and if we go into low-tech macro mode, we can see that that has an output of 5 volts at 2.0 amps. And the power bank has an input of 5 volts at 2 amps max, so that seems like a pretty good match. Now the power bank is completely empty, which you can see if I press the button, it just flashes the first LED and it won't switch the outputs on, it won't switch the torch on, it's completely empty. So I completely drain this thing, always through this tester. So let's power this up and see what the figures are. So let's plug this into another power bank. And here's the magic number. Can we see it? I'll go into macro mode. And the total capacity is 13,925. Well, now you're probably thinking, oh, and this keeps resetting, because this thing keeps resetting. You're probably thinking, well, now that's not very good. 13,925 milliamp hours for a power bank that's rated at 22,400. But we've got to do some mathematical conversions. So 13,925. Now the first thing I should say is that this tester only writes to its E² prom about every 10 counts. I think partly to try and not use too many of the write cycles. So every time I unplug this, and I did unplug it numerous times because I charged all sorts of different devices from the power bank, including other power banks, this power bank I also charged, and my Nexus 4 phone, which I'm filming on now, and the Nexus 7 tablet. So I'm going to give this about 100 counts to account for around 10 times disconnecting this thing. So I'm going to add 100 to this. So that gives 14,025. Now the next thing is inside this power bank there is a boost converter which converts the 3.7 volts on the cells to 5 volts at the output sockets. And boost converters have an efficiency rating. Now a good boost converter should be about 90% efficient, so we will get losses of about 10% in the electronics. So the way I'm going to offset that is I'm going to divide by 0.9, that's the 90%. So that raises the figure again, that gives us 15,583. Now the next thing is that the milliamp hour rating on this device is for a 5 volt output, and what we want is the milliamp hour rating at 3.7 volts inside the cells of the power bank. So what I need to do now is multiply by 5 and divide by 3.7, the nominal voltage of the cells. And that gives us a result of 21,058. And I don't think that's too bad. The thing's rated at 22,400. In reality, the cells held about 21,000 milliamp hours, 21 amp hours. Now, a power bank that has very few bells and whistles, and this has very few bells and whistles, it has a torch, but that's about it, but that has a claim of high capacity, really needs to live up to that claim. And in the main, this thing does. 21,000 milliamp hours for a 22,400 milliamp hour claim. So I think this is really impressive. And I do like this power bank, and I use it pretty much every day, which was why I didn't really want to take it apart. So I was quite pleased when Lewis sent me those photographs. Now I've got another photograph here, which is the electronics, and I'll just quickly whip through this. There's not much to say here that we haven't already said about other power banks. This is obviously a microcontroller here. These are fairly recognizable as the 8205 MOSFETs, which disconnect the batteries when they go under voltage. So that's the situation I've got now, having discharged it. This here looks like a SOT23. That's probably the DW01 battery protection IC. We can see the sockets at the top here and the LED. Can't see the inductor. That must be on the other side of the board. Now I just wanted to say a couple of other things about this unit, which I didn't mention initially. These 4 blue LEDs are very low brightness, and that's a good thing, because if you're using this at night, they don't fill the room with light. In fact, they're just the perfect brightness. They're bright enough to see in daylight, as you can see here, but dim enough that they don't fill the room when you don't want them to. The torch, on the other hand, and I've plugged this in, I'm charging it now, is easily bright enough, and the main thing I found it useful for is finding these sockets when you're trying to plug something into this thing in the dark. Now the next thing is it's quite difficult to get an idea of size. I mean, we know that most of this is filled with 18650s, but just for comparison, here's a can of cola, just so that you can see roughly how big this thing is. Now, one thing that occurred to me when I saw this photograph with all those 18650 cells squeezed inside this plastic box, what about buying this thing just for the cells? So here's the EC Technology 22,400 milliamp hour power bank on amazon.co.uk, and the price here is £36. Now, if we assume that the case and the electronics have no value, and they probably wouldn't if you took this thing apart, then that makes the cells £4.50 each. And £4.50 for a 2800 milliamp hour cell, although in my real world test I rate them at 2625 milliamp hours, that's not a bad price. So there is some justification for buying this power bank, breaking it apart and using the cells for something else. But on the other hand, 3.7 volts isn't a particularly useful voltage. 5 volts, on the other hand, is a very useful voltage. So there's a lot of reasons for keeping this as a 5 volt power bank because it has a lot of uses. So, to sum up, I think this is an excellent power bank. It's the highest capacity power bank I've got, and therefore, actually, it's the most useful. Too useful, in fact, to take it apart, break it open and take the cells out, so I'm going to leave it very much intact. And I'll put a link in the description to the power bank on amazon.co.uk, and if I can find it on amazon.com, I'll put a link to it on that website as well.